think you will. All right, so 1-6A. Trig was in chapters 4, 5, and 6, which we started at the beginning of the semester. Second semester, yeah. Even Ram did too. We're just going to call this Trig topics because it's going to be a lot of different stuff that maybe you remember and maybe you don't. Trig topics. Yeah, maybe a little bit. Okay, I've got 4 parts today, and we're going to start with one of the most basic things about trigonometry, which would be the unit circle. The unit circle. All right. Do you remember it? Yeah? Some people like it. Some people are like, nope.
That's where I failed my grade.
Yes, Jack. Yes, let's not do that this time. Let's learn it this time. All right, so a unit circle is basically just a circle with radius 1. Okay, so there it is. Radius 1. So if you went over here to this point, this would be the point 1, 0. And this point up here is the point 0, 1. And the equation of that circle is x squared plus y squared equals 1. And if you go to certain angles from the x-axis on the unit circle, we have some very special angles. We have that one, and that one, and that one. Okay? And these angles come from when you learned in geometry, when you did the 30, 60, 90, 45, 45, 90. They come from the right triangles that are formed. And this one up here, I really should have drawn this bigger. This is the angle pi over 3. And that's when you got into radians and you were like, what? But pi over 3 is just, how many degrees is that? 60. 60 degrees. And so the coordinate point at the angle on your circle at pi over 3, that point is the point 1/2 rad 3 over 2. And if you were to plug those numbers in for x and y and square them and add them together, it would equal 1. They actually work in the equation of your circle. All right, this one, the middle one, is pi over 4. And pi over 4 is how many degrees? 45. And you remember that point? Yes, rad 2 over 2, rad 2 over 2. This is going to be really messy on here. Yeah, but... All right, and then the last angle, the smallest angle that we're concerned with here is pi over 6. That's this angle here. And that would just be pi over 3. Those, all of them switched. Rad 3 over 2, 1/2. And pi over 6 is 30 degrees. Okay, so all these points on here, they all come from right triangles and Sohcahtoa and stuff. But we know that all of the points are going to be cosine theta, sine theta. So if I wanted to, for example, number 1, I want to evaluate what the sine of pi over 3 is. Okay, I would go to my unit circle, and I look at pi over 3, and the sine there is the y value, which is rad 3 over 2. Okay, and you can do that on your calculator, but it's not going to give you that. It'll give you 0.866 or something like that. Okay. So evaluate, say, for example, the tangent of pi over 6. And do you remember how to find tangent? Sine over cosine, or on the unit circle, tangent of an angle is y over x. Or sine over cosine is fine too. So it'd be 1/2 over rad 3 over 2. And you can't leave it like that, of course. You have to flip it. 2 over rad 3. And then rationalize. You can't leave it as 1 over rad 3. So that would be rad 3 over 3. Barf, right? Do you remember this? What are you guys looking at? Not this, because this isn't funny.
He's saying what examples of occupations involving this kind of...
Oh, so something totally not this. Okay, great, good for you. All right, the other thing is, if you had to find values of sine, cosine, tangent, all that stuff in different quadrants, all you have to do, remember you just had to memorize the first quadrant, And then you had to memorize which one's positive and negative in these quadrants. Remember what we used? All saints trust Christ.
Why did I look at Trevor too when she said that? Because of his little thing.
Yes? Did you guys learn this in RAM at all? No.
I don't know.
Yeah? Well, or all students take calculus or AX going that way. Basically, all six are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent, see the reciprocal functions always go with them, are positive here. And then cosine and secant are positive there. So for example, if I wanted to find then number 2. So finding these or evaluating your trig functions in quadrant 1 is not that bad. But what about when you have to evaluate, say, the sine of negative pi over 4? What's wrong?
How did 2 rad 3 turn into rad 3 over 3? So it's 1/2 over tangent pi over 6?
Yeah, let's go back to that. So you have 1/2 over rad 3 over 2. So you take the bottom and you flip it and multiply, because division is the same thing as multiplying by reciprocal. And so then you get 1 over rad 3, and you're not allowed to leave radicals in your denominator, so we're going to multiply top and bottom by rad 3 over 3. So you get rad 3 up top, rad 3 times rad 3 is 3. You always got to rationalize all of your answers here. Okay, so this one?
Does that work? Because last year
Yeah, last year it didn't, but I always made people do it. I don't know if Mrs. Pfeiffer did or not. Sine of negative pi over 4. Okay, what I do is this. I think about what sine of pi over 4 is, and it's rad 2 over 2. And then I think about, well, what quadrant is negative pi over 4 in? That's going this direction. And is sine positive or negative in quadrant 4? Negative. And so the answer is negative rad 2 over 2. Okay. You could also do like the cosine of 2 pi over 3. It's like A and B. Cosine of 2 pi over 3. Well, I would use its reference angle, which is pi over 3. So what's the cosine of pi over 3? That would be 1/2. But what quadrant is 2 pi over 3 in? 2. And cosine's negative there. So the answer is negative 1/2. Okay? So it's kind of like two different things at once. Alrighty. How about conversions? This is still in part A. Conversions. So your conversion factor is that pi radians is equal to how many degrees? 180 degrees. Perfect. And that's your conversion factor. So if you ever want to figure out something like number 3, convert 5 pi over 6 to degrees. Okay. Convert 5 pi over 6 to degrees. Okay. So what you want to do, you know it's going to be less than 180, right? Because 6 pi over 6 is 180. Okay. So you would go 5 pi over 6 times, we want this to go into degrees. So we're going to put 180 degrees over pi radians. So your radians, 6 goes into 180 how many times? No? 30 times 5? No? You don't like doing that? If No, what if you don't have your calculator? You would go 6 goes into 180, 30 times, 5 times 30 is 150 degrees. You guys should do some stuff like that. Chill. You chill. Okay, number 4. Do you know how many degrees 1 radian is? Not pi radians, but 1 radian. Let's take 1 radian, convert to degrees. Okay, 1 radian. Not pi radians. Pi is 3.14 radians, right? Okay, so 1 radian times 180 degrees over pi radians. The radians will reduce. 180 divided by pi. Beep, boop, beep, boop.
You didn't put radians on that one.
You could have.
What would have canceled it out?
Radians would have. Yeah. They just don't say radians a lot. You just know that it is. All right, so 180 divided by pi is about 57.3 degrees. Okay? So you guys know what a radian is, right? You feel pretty comfortable with radians? A radian is when you have the radius of a circle and you go a distance of that radius, that makes 1 radian. Yes, this is 1 radian right there. Because this right here is equal to that. And then you go another one that's the same distance, and that's 2 radians. It's the angle. No, that's the arc length. And then you go a little bit more, and guess what you get right before here? You get 3 radians. And then all the way to here is pi radians, which is 3.14. I know, people don't think of it, they just remember pi, and they don't think of it actually as numbers. Okay, so, let's do one more. Let's convert 280 degrees to radians now. 280 degrees to radians. All right, so we're going to multiply this by pi radians. You don't have to write radians, but you can if you want to, over 180. And I want this to be in a fraction form with pi in your answer. So you'd go 280 divided by 180 on your calculator, hit math fraction, and the answer would be 14 pi over 9. You don't have to say radians. We just assume that it is, okay? It depends on the question. We don't usually do our calculator in radian mode because when you're doing radians, you do it by hand most of the time. All right, let's move on to part B. Part B, Jack, what are you watching? You're doing homework?
Shorter or longer than
It's shorter. I'm sorry, I didn't mean to bother you, Jack. All right, we're going to do arc length. You and Peyton. Arc length, if theta is in radians. Oh, remember theta? There's our good friend theta. If theta is in radians, then S is equal to R times theta. What in the world does that mean? Okay, let's say we have a circle and we have a central angle. Here's our central angle. Okay. And in here, this is theta, and it has to be in radians. If it's not, you need to convert it. R is the radius, and S is the arc length. Okay, that has to do with the radians of a circle. And so you're going to get something like this, number 6. I have a little chart to fill out. They're going to give you an angle, maybe, radius, and arc length. Okay? And they're going to give you 2 out of the 3 things, and you have to find the 3rd thing. It doesn't, and it's just going to change. All right, so let's do this one. Let's say that the angle of our central angle is 7 pi over 9. The radius of our circle is 5, and we need to find the arc length. All right, this is probably the easiest out of the 3, okay? You're just plugging it into this formula that you have memorized that says the arc length is the radius times the angle in radians. And so this would be S would equal 7 pi over 9 times 5. And you can go ahead and give that to me as a decimal. Let's see, times 5. And it's 12.2. Okay, you just plug it in. It depends on what radius. If the radius, let's say the radius was 5 centimeters, then the arc length would be in centimeters also. I'm glad you noticed that. All right, part B. Let's say that the angle is 100 degrees. The radius is the question mark, and the arc length is 20 inches. Yeah, first you have to change it. You have to change theta. Theta is 100 degrees, so we're going to do 100 times pi over 180, because you got to get rid of those degrees. So you get 5 pi over 9, so that's what theta is. And we're going to plug it into, and we're trying to find the radius here. So we're really going to do arc length divided by the angle is equal to radius. Yeah, decimal would be perfect. So 20 divided by 5 pi over 9. Pretty gross, huh? 11.5? Anybody else get that?
Yep.
Me too. 11.5 inches. Okay, and then finally the last one is when we're not given the angle. We got to find the angle, and it says the radius is 12 centimeters and the arc length is 30 centimeters, and we need to find the angle. So theta is equal to S over R. So theta is going to be the arc length divided by the radius. And you can put that in decimals too. So that would be 2.5 radians, 2.5 radians. That is not in terms of pi. Okay, pretty good. All right, part C. Halfway done. Hang in there. You got this.
I went really narrow along the side, so I have to put C.
You got this. There is. All right, the next one is something that you might be pretty comfortable with. And that's our good friend, Sohcahtoa. I know, right? I always refer back to that too. Sohcahtoa is really for right. What? You don't like it when I do what?
You put Sohcahtoa all together. Like,
Yes.
I don't like that.
Sohcahtoa.
Why don't you just leave a space between them?
Why don't you tell me how to do my job? How's that? How's that? Is that good? Does that look good?
No.
Well, do what you want to do on your note page. More suggestions. We all know where they go. Okay.
That's a nice straight. Nice.
Thank you. I practice. Okay. All right, so there's theta. Here's x, here's y, and this is r. So this is for really when you're not on the unit circle a lot of times. Wow, Kevin, you got a mustache going. Oh, okay. Yeah, we need to shave that thing. Dang. All right. So Sohcahtoa basically is this. Here are your 6 trig functions. No? You've had it this whole year?
I can't hear. It's just like shade, it's just a shadow.
Oh, okay. That's your 9:30 o'clock shadow?
Yeah.
Okay, perfect. All right, sine of theta, and we're going to do Sohcahtoa. We're going to do the so part. Opposite over hypotenuse. Okay? And when you're on the unit circle, r is equal to 1, and so sine is always the y value on the unit circle. And then let's do his little counterpart, his reciprocal function, which is cosecant. And that one is you just take the reciprocal functions. So that would be r over y, as long as y is not 0. If y is 0, then cosecant is undefined. All right, let's list them all. Here we go. cosine of theta is adjacent over hypotenuse, x over r. And then his reciprocal function is the secant of theta, which is r over x, as long as x is not 0. What's wrong?
We're using RYX and not just
R's for the radius.
Yeah. R's for radius.
R's for radius.
X is the x-axis, and y is the.
What other letters did you use?
yeah, what other letters? Like opposite, adjacent, hypotenuse.
Well, you do that.
Tangent of theta, opposite, toa, opposite over adjacent, so y over x, as long as x is not 0. So tangent has points that it's not defined, so it's not a continuous function. And cotangent of theta is x over y, as long as y is not 0. And there they are. Okay, so let's do this now. What number are we on?
What was the little comment you said
7.
after
Tangent?
Yeah, you said something after.
Oh, it's tangent's not a continuous function. It has points of discontinuity when x is equal to 0.
Oh, because like sine and cosine are.
Yeah, sine and cosine, they're continuous. And then all the rest of them aren't.
The graph of tangent.
Yeah, remember tangent looked like a cubic function, like a whole bunch of them? Like, nope, don't remember that. Okay, number 7. Let's say that we are given that the cosine of theta is 4/5 and sine of that same angle is less than 0. We need to find all 6 trig functions.
This is so much.
It's so much work. It's not hard. It's just.
It's not bad, especially when it's nice triangles.
Shouldn't we draw?
Yes. Okay. So the first thing you need to do is you need to figure out what quadrant you're in.
1.
Nope.
Oh, 2.
Nope.
Yeah?
Nope.
Oh, wait, no, 4.
4. There you go. Cosine is positive
Wait, what's
and sine is negative. So the only quadrant where cosine is positive, see it's 4/5, and they're telling me that sine is less than 0, we're going to be over here in quadrant 4. I don't know what angle that is, but I'm just going to label it theta. And they give me cosine, and I know cosine is adjacent over hypotenuse. So this is 4, 5, and this is the old 3, 4, 5 triangle. And this would be -3. Don't forget it's negative. That's, I know.
You said it.
People forget that. And now you just have to find the rest of them.
And the radius is always positive.
Yes, exactly. R is always positive. It's x or y that's going to be negative. Okay, so the sine of theta is going to be toa. No, so. The sine is toa. Sine is so opposite -3/5, and it should be a negative answer. Cosecant of theta is just going to be the reciprocal, so -5/3. We already have cosine. They gave that to us as 4/5. So secant of theta is 5/4. Tangent, toa, opposite over adjacent, so -3/4. And cotangent of that angle would be -4/3. See, that was pretty fast. Sometimes when you have like an ugly, like a radical, and you have to rationalize everything, that's when it gets really bad. But we like to deal with really nice Pythagorean triples.
It was only really bad with tangent when you have a bracket.
Okay, part D, last part. And this one, this is probably the trickiest part of trig that you learned besides all those identities that you had to do. We're going to do inverse trig functions. Inverse trig functions are not reciprocal trig functions. They're inverse. Okay? And as soon as I write something down, you'll probably remember it and maybe groan a little bit because these are kind of tough. See, here's the thing. We just learned inverses, right? Last week. And if you take the sine function, you don't need to write this down. I was just going to show you real quick. If you take the sine function and you want to try and get an inverse trig function from that, you can't because it's not one-to-one, right? That is not a one-to-one graph. So this is what they do. They say, you know what? We're only going to take a little part of this graph. Just this part right here Just this right here. We're going to ignore the rest of sine, and we're going to just take that and inverse it. Okay, so when you're getting answers, your answers are going to be in, this is really quadrant 4, and this is quadrant 1. I know, right? Okay, so let me go ahead and show you how to do these. Okay, so we're going to have 3 inverse trig functions. We have sine inverse of theta. We can call it theta. No, it's not sine inverse of theta. Sine inverse of A. We'll call it A. Let me undo that. Okay. You also have heard it called arc sine. Were you? That is a terrible time to be sick. Okay, so we have sine inverse or arc sine. And basically, what happens is when you're taking the sine inverse of something, you're trying to think sine of what angle gives me that value A. You're going backwards. Okay, but you can't just pick any old answer. Your answers have to fall in quadrant 1 if it's positive, or quadrant 4 going the opposite direction if it's negative. Okay, so when you're evaluating sine of theta equals A, theta has to be between negative pi over 2 and positive pi over 2. Okay, if you look at this graph right here, see this? This is negative pi over 2 and positive pi over 2 on the domain. In the inverse, it's your range, it's your output, because domain and range switch, okay? All right, cosine inverse of A, or arc cosine. This one is going to be quadrants 1 and 2. So if your value is positive, you'll be from 0 to pi over 2. If your value is negative, you'll be from pi over 2 to pi.
Can it be quadrant 3?
Yeah, because isn't it also negative?
Because it has to be together. You're only getting, yeah, it's making it 1 to 1. Because, you know, cosine, I have 2 values on the unit circle that cosine could be. But I need one value because I'm trying to do 1 to 1.
Oh, because on a graph, if you were to go one more, would it be 1 to 1?
Yeah, yep,
But could you, if you wanted to, do, like, it'd be make it more complicated, but could you do quadrant 1 and quadrant 3?
Yeah, but they want the inverse to be continuous function.
Okay.
That would be skipping over an entire quadrant.
Still-
Yeah, I mean, yeah, those are, yeah, but they're not the right answers, though. But you're still right, yeah. Okay, and then tan inverse is going to be the same thing as sine inverse. This way and that way, positive and negative. And negative pi over 2 to pi over 2. So if you gave me an answer that's outside of any of these ranges, then your answer is technically wrong. Okay, it's not correct. So let's go ahead and practice some. What number on 8? Yeah. Number 8. Okay, so these are probably the most tricky out of all the problems that, a lot of the problems that we did last year. So let's just go ahead and evaluate, and we'll do as many as we want to, which is more than 5, Jack. All right, here we go. Sine inverse of rad 3 over 2. Okay, anytime you're trying to find sine inverse, cosine inverse, or tangent inverse of a positive number, you're in quadrant 1 no matter what. Okay? What this is saying is this. Sine of what angle gives me the value of rad 3 over 2? You're going backwards. You know how we evaluated sine of pi over 6 equals this? We're doing the opposite.
That's why we need to know that in the unit circle.
Yes, exactly. And so what angle, and only quadrant 1. You know, sine is positive in 1 and 2, but you cannot say the quadrant 2 answers. So what is it?
3?
Pi over 3.
Pi over 3 or pi over 6?
3.
Pi over 3. The y value. Okay? Now, I think sine inverse and tangent inverse are pretty easy in a way. Because if I needed to find the sine inverse of negative rad 3 over 2, okay, it's a negative number, what I'm going to do is I'm just going to take this answer right here and make it negative. And that's true because, you know what? Sine is an odd function. When you plug in a negative, you get a negative. Anyways, you don't care about that. All right, so sine is this. My answers can go that way and stop at pi over 2, or they can go this way in a negative and stop at negative pi over 2. Those are your answers, okay? All right, let's try a cosine inverse now. Cosine inverse of rad 2 over 2. Cosine inverse of rad 2 over 2. So where is cosine of what angle gives me rad 2 over 2? You should know that one pretty quickly. Pi over 4. That's the one where you don't really have to think, is it pi over 3 or pi over 6? It's just pi over 4. All right, so when I do a negative rad 2 over 2, you can't say negative pi over 4 because cosine is actually positive in quadrant 4.
So 3 pi?
Yes, you're in quadrant 2. Okay, so cosine for positive is quadrant 1. Cosine for negative values is quadrant 2. And that would be over here at 3 pi over 4. Do you remember doing these, you guys?
Yeah.
Yeah, they were horrible, huh?
In terms of pi would be positive for cosine technically?
In quadrant 2, yes. Oh, no, negative.
Well, there's,
She's just saying, like, instead of negative pi over 4, it's going to be 3
Oh, all of these answers, yes, yeah. So cosine, your answers are going to be in there. Yep. So if you tell me the answer is like, you know, in anything, like even if you went negative, it's still wrong. Your answers have to be from 0 to pi. All right, let's try one more. How about tan inverse of rad 3?
I hate these.
I know.
'Cause I-
These get tricky, huh?
pi over 3.
Yep.
Okay, so the way I look at these is,
oh, wait, you taught us
oh,
the same.
yeah.
If it's rad 3 over 3, then 6 is 33.
Right. Okay, so yeah, we did that last year. So those are two of the ones that it can be. So if it's rad 3, then your answer is pi over 3 because that only contains 1 3. And this 3 and 3 make 6, so it's pi over 6. That was just like a little trick and you remembered it. That's pretty good.
That's the only way I can do it.
It's just too much work. I'm gonna figure it out.
If not, then you're doing y over x and you're doing rad 3 over 2 over 1/2.
Yeah, but it's
And this one is 1/2 over rad 3 over 2.
I would end up putting like all of the numbers in and just trying to figure it
Yes,
out.
yes. So if there's 1 3, it's just 1 3, and if there's 2 3s, then that adds up to 6. I know, I always like that too. Okay.